information should be given. Okay, first of all, IP addresses. So what is a IP address? Guys, I already started a recording. Okay, so once I done this small topic, then I will take in attendance. What is a IP address? Unique. Unique. Uniquely, actually, it is a uniquely identify a device in network. Okay, so what is an IP address? Uniquely identify a device in the network. Okay. In network. So like this, uniquely identify a device in the network. So that is called a Ipv4. I just trying for a spelling. Okay, that's it. So guys, if you don't know, if you don't unable to tell some other answer for a IP address. But here why I am telling like that, because of some people will tell an answer like what is an IP address and unique address. Immediately people tell it's a unique address. No, it is wrong answer. Unique address meaning is MAC address. Okay, MAC address is unique address. IP address is not unique address. Okay, it is not a unique address. It can be a changeable. IP address can be changeable. All communications by IP address only. Numerical address. So numerical representation of host or domain kind of stuff. Means a PC or a domain we can identify numerically. Numerically means through numbers. Okay, this is also secondary. Okay, try to keep it very less at the time of some interviews. Basically, outside interviews are no problem, but be careful when you speak. You have to make sure what you are speaking, because if you say unique address is MAC address, not IP address. Okay, IP address is logical address. MAC address is physical address. Remember, MAC address is physical address. IP address is logical address. IP address is logical address. MAC address is IP address is a logical address. MAC address is physical address. Through IP address, we can create a logical topologies. Using IP address network, logical topology. We have already seen physical topology. We have seen physical topology, bus topology, ring topology, kind of stuff. But here we seen logical topology using IP address network. So we create a logical topologies. So numerical representation of host or a domain in the network. The network. Okay, so important point here it is. Again, I'm writing this one, which is I already told. All communications by IP address only, not by MAC address or a name. Means either domain name or host name, FQN name, any name, URLs, not with that one. We are using URL because of we remember the names, right? For example, you remember your friend's name, but you cannot remember your friend's phone numbers, right? So that's why we are using names, but originally we are communicating with the numbers only. Okay, so that is what IP address it is. Okay, to communicate from one device to another device, we use IP address. Communicate from one device to other, we use IP address. What is to communicate? Means I have to send a message, so I have to send a to address we have to give, right? So like a to address from address is there, like a source address, source IP address, and destination IP address. Look at in a communication we have a to address and from address. We are communicating, so we have a true address and from address. It is like a to address is a destination IP address we use here. From address like a my address I'm sending to someone, so that is to address. From address, my address is like a source address, source IP address. This is about a small part of IP addresses, guys. It's a logical address. Uniquely identify a device in the network. So yeah, in the network you have a computers and you want to identify that device to communicate. So we use IP address. Okay. So numerical representation of a host, like you are telling, this is the particular PC IP address or this is particular domains IP address. We can able to tell in the numerical form. All communications by IP address only. We cannot communicate with the MAC address or a name of the computer or a domain. So we need an IP address for communication. Okay. So to communicate from one device to another device, we need a IP address. Meaning is I want to talk to someone, so I need their phone number, right? So if I know their phone number, I can able to send it. Like I can able to call them. So when he received, he got my phone number because of from address to address kind of concept, right? So if I send a letter to someone, I have to write a to address to Ranjit Kumar, to Kamala. Okay, Kamala, sorry. Okay, to Kamala address, like it is from Latif. Okay, so like this. So from address to address is there. Same thing when you are communicating, you are sending a message. So there is a source address and destination IP address is there. Okay, so what is the topology we call in the network, in the IP address network? The topology is a logical topology. Why logical? We divide the topology, we divide the group of network into group of system into a network by IP address. Logically, you can get it. So that is what. So again, MAC address cannot be changeable. IP address can be changeable. MAC address is called a physical address. IP address is called a logical address. Guys, understand this point? IP address. IP addresses are basically okay. So IP addresses are basically two versions are there, not two types, two versions. IPv4 means version 4, IPv6 means version 6. IP address kind of stuff. Okay, so we are using IP addresses. Not only IP address, guys, there is some different type of communication protocols are there to communicate, but here it is in our general communication is by IP address only. Okay, so IPv4, IPv6 version 4, version 6. Okay, so last time there is a question: what is the difference between IPv4 and IPv6? Here is a point. IPv4 is a 32-bit in a binary, so it is a 32-bit length. Okay, so length of IP address is 32-bit length size. So like 010101, it's a 32 binary numbers are there. So here it is 2 to the power of 32 is equal to 4.3 billion IP addresses. If you want, you can calculate from it. So 2 to the power of 32 is around 4.24. You can see it is this is called thousands, millions, billions, means 4 billion 294 millions 967 thousands 296 IP addresses we are getting. So less than or more, like it is approximately we are making 4.3 billion. Billion means 1 billion is equal to 100 crores. 100 crores. 1 billion is equal to 100 crores. It is around 429 crores. Okay, this we have to calculate, like this is a lakhs, right? And this is a crores. Now this is the one single part. So 429 crores of IP addresses in a single IPv4 address. Okay, guys, understanding?
Yes, sir.
It is a 128 bit length. IPv6 is 128 bit length. Means if you write IPv6 in the binary code, so it is like a 128 bits. So 2 to the power of 128. So it is around 3.4 billion of IP addresses. And easily say it is around 4.3 into 10 to the power of 38 number of IP addresses. If you want to calculate, you can try. So number of IP addresses 2 to the power of 128. It is 3.4 into 10 to the power of 38. It means 3.4 billions of IP addresses, means large amount of IP addresses we are using. Of course, in publicly we are using IPv4. In the entire world is communicating using a IPv4 only. Only certain set of certain private sectors only using only 1 or 2 countries and only private sectors. For example, Reliance using IPv6 for internal communication for their customers or Geo Internet services using IPv6 and IPv4 both we are using. Okay, IPv6 and IPv4 for their internal communication and internet communication that are using. Okay, if you take Japan, Germany kind of countries, they may using IPv6 for entire country. Big countries like US, Australia, Russia, India, we are almost all countries. We are still using a IPv4 only. Okay, so here it is. It's a decimal format. Actually, it is a binary part, but it is when we are writing IPv4 IP address, we write in a decimal numbers. Here it is, we use hexadecimal numbers. Okay, so we use hexadecimal numbers. Okay. Of course, we can tell some more extra things. For example, okay, it's divided to 4 octets. Okay, so for example, so not for example, 32 by 4. 4 octets means 32 by 4. The meaning is how much for 1 octet? 8 bits. 8 bits in a 1 octet. This is the first octet. Second octet. Like this. There is a 4 octets divided into 4 octets. Octet means 8 bits. Okay, octet means 8 bits. So 8 plus 8 plus 8 plus 8, 32 bit number. Here it is. This is also same thing, but a small difference is there. It is total number of IP addresses are total bits are 128. Total bits of 128. So okay, so 4 bit is equal to 1 hexa. One single hexa number is 4 binary bits. Single hexa number is a 4 binary bits. So obviously 128 divided by 4 first of all means we are writing a hexadecimal number. So each hexadecimal can be written in a 4 binary numbers. Okay, we have 128 binary numbers divided by 4, so it is 32 hexa numbers will be there. Means one single IPv6 having 32 hexa numbers. These 32 hexa numbers are divided by 4 and become 8 blocks. 8 blocks. Totally 8 blocks are there. Okay, so you can simply write 8 blocks in it. Okay, so hexadecimal format. Each hexa number is 4 bits. Okay, so 128 bit length of IPv6. Okay, and it's a 128 by 4 become 32 hexadecimal. So totally 32 hexadecimal numbers in a single IPv6. Okay, each 4 hexa numbers. 4 hexa numbers combinedly a block. Okay, so you can go through that one also. Okay. 4 hexa number, one block, called a one block. So 32 hexa numbers by 4. It is a 8 blocks. It is there. I will show you the example block case kind of stuff. For example, I'm using a like this. This is 4 blocks are completed. This is how it is. It is okay. The difference is here. Each octet divided by dot. Here it is. Each block divided by colon. Okay. Each octet divided by dot. So when you are reading, so it is a like it. Okay. Here it is. I've written, but I want to give some example because there it is. I've written example, right? So here I am writing an example from here. Okay. The example of IPv4. This is the example of IPv6. Okay, these are the few points. Again, I will add some more points. Don't worry. Okay, so the first part points. Point number 1. This is entirely point number 1, guys. IPv4 32-bit, IPv6 128-bit. IPv4, so 32-bit means 4.3 billion IP addresses we are getting, but IPv6 is like a unlimited type. Means 4.3 billions of IP addresses we are getting. Okay, IPv4 look like a decimal numbers. IPv6 is a kind of hexadecimal numbers. Okay, it is divided into 4 parts. Okay, 4 parts. Each part we call it as a octet. Okay, so it's a 32-bit and it is divided by 4 means it contains 4 bit. Each part is a 8-bit. Totally 4 octets will be created. Octet means 8 bits. Okay. So that division we call the division. The point is here it is dot. So 192.168.2.110. You know, some people their mind or something even be told how to spell. People will spell in their way only. 192.168.2.110. Okay, it's not point, guys. It is a dot. 192.168.2.110. That is a IPv4. And IPv6 again, it is a 128-bit length of a one single IP address. Okay, it is represented in a hexadecimal format. Hexa means each digit is represent is equal to 4 4 binary numbers. Okay, so then 32 hexadecimals in the single IPv6. Okay, and it is okay. This is a example. So totally 8 blocks. Each block is divided by colon. Okay, there's some more examples are there, so we'll see that one later, but not later. I'll show you also now. Unicast type of IP addresses, multicast type of IP addresses, broadcast type of IP addresses are there. So IPv6 having a unicast, multicast, anycast, so no broadcast. Okay, so what happened? IPv6 no broadcast, only unicast. Anycast. Next, there is some IP addresses like this. Okay, this is the reserved IP address. We don't use it for our direct communication. So we use it for protocols. We use it this kind of IP addresses, but not for a host purposes. Same all zeros will represent here colon 0. 127.0.0.1. So loopback IP address or local host. What is a local host? Means my PC having some IP address, but beside another PC having another IP address. Maybe my tablet having some IP address, my mobile phone having some IP address, but all common together for every PC for itself. There is IP address called a 127.0.0.1. Okay, so this is called a local host or loopback address. In IPv6, it is a colon 1. So unicast addresses by IP classes, it's a class A, class B, and class C. Unicast are global unicast. It is this is meaning of it is range is there like that. Meaning is so 2000 starting for part is there no. So this is the range. So global unicast IP address. Next one is link local. You may see in this IP address. FE80. So link local unicast address. You can see go to so I have IPv4 and I have a IPv6. It is a link local FE80. FE80. Okay, which is by default generated from our so multicast is multicast. D. Okay, multicast range is also there in IPv6. You can try to check it. Okay, so this is a two unused IP addresses colon 0 in a IPv6. Okay, in IPv4 it is 0.0.0.0. So and loopback and localhost IP address here 127.0.0.1. In IPv6 it's called a log colon 1. So these are the main basic differences, and also you can try to find the ranges like a global unicast range, multicast ranges, unicast ranges. So this is IPv4 IPv6 difference. So here it is. IPv4 is divided into classes. Okay. So totally 5 classes. A. Originally there is a big sequence is there. I'm not going with that big sequence because information is important, because lack of time will also not joining. So it's a 0 to 127. In some test book it shows 1 to 126, which is also correct, because 0 here we are not using. It is a result for some other purpose or services. And 127.0.0.0, this is a local host IP address which we are not able to use for a communication. Next. 128 to 191, 192 to 123, 224 to 239, 240, 5. The meaning is, it is 8 octets, means 2 to the power of 8. So 2 to the power of 8, the maximum each octet size is 8 only. So, here 8 bit. It is 8 bits. So 2 to the power of 8. So 256. So exactly, if you write 0 to 255 only, not 256, minus will be reduced. Minus will be like if you count, total is 256, but if you count 0 to 256, 255, 0 to 255, it is 256. Okay, so IPv4 is divided into classes. Okay, each octet is 255. 0 to 255.0.255.0.255.0.255. Okay, octet 8 bits. Okay, so each octet is having a 255 only. Okay, the point is people are not at all. Okay, I'm getting a lot of sleep also. No problem. So these are the total IPv6 ranges, guys. In this one, class D, we don't use it for assigning IP address. So, okay, this is purpose is multicast. Unicast, multicast. This is R and D purpose only. So very special cases are some research for research purpose, or maybe reserve it maybe in future uses they may use it, but currently it is reserved. Class D, class E are not used to assign IP address to host. Okay, we don't use to assign IP address to a host. So that is one thing. Same for 0.0.0.0 and 127.0.0.1 don't assign to your host. Host means NIC. Don't use it. It is there by default. And also we don't use it. 169.254.0.0 x.x. So why? Because it's the automatic private IP address. PIPA automatic private IP so what will happen if host unable to IP address or fail to get IP address from DHCP server system, then IP address from then. So what is the range? So this is also we don't use it. Okay. So class A, class B, class C are a unicast IP addresses. We use the unicast address, but 0.0.0.0, 127.1.0.0.0.0 and 0, anything starting with 0 and anything starting with a 1, also we don't use it. This is all. So this is the some parts of IPv6. So IPv4. First of all, IPv4 IPv6 difference. What is IP address? Okay. and their classes and their ranges. Okay, guys. So yeah, I will stop. I will tell a part 2 here. IP addresses, their network portion, host portion, how to ping. Okay, and also what is private IP addresses, what is NAT and PAT. I will tell in a short notes. Okay, take a break. Take 15 minutes break only, not more day. Okay, so here it is. Yeah, 4:15. Okay, don't sleep. Have tea or coffee.
15